Let's go to page 810. This is lesson 12.3. This lesson is to find surface area of the pyramids and cones. A pyramid is a polyhedron, okay, so the base is a polygon, okay, in which the base is a polygon and the lateral faces are triangles with a common vertex called the vertex of the pyramid. Okay. So this is what a pyramid looks like. Again, the base is a polygon and all the faces are triangle and meet on the top of the vertex. The intersection of the two lateral faces is a lateral edge. So lateral edge is the edge on the side of the pyramid. The intersection of the base and the lateral face is a base edge. So this is a lateral edge and this is a base edge. Okay. So again, the edge on the base is called a base edge, and the edge on the side is a lateral edge. The height of the pyramid is a perpendicular distance between the base and the vertex. So the height is from the vertex and it goes perpendicular, so it goes straight down. Okay? Whereas this height over here, the height of the face is called a slant height. Then usually they use the H for the height and they use the L for the slant height. Okay. So make sure you know the difference between the slant height and the height. Okay, again, the height is from vertex, it goes straight down. The slant height is the height of the triangle. It's from here to here. Okay, so basically it's the apotheme of the triangle. So from the vertex to here. Okay, so make sure you know the difference between the two. Okay. A regular pyramid has a regular polygon for base. Okay, so when you see the word regular, it means the base is a regular shape. Okay, that means all sides are congruent. Okay. And the segment joining the vertex and the center of the base is perpendicular to the base. Okay. Okay. So again, that is the height. Okay. It says the lateral faces of the regular polygons are congruent isosceles triangles. Okay, so when it's a regular, okay, that means all four sides are congruent. That means all the triangle, the side would be congruent triangles, and it'd be all isosceles. The slant height of a regular pyramid is the height of the lateral face of the regular pyramid. Okay, a non-regular pyramid does not have a slant height, like this one over here. See, it's non-regular, so all the height of each triangle is all different. So you do not have a slant height. Okay. Okay. Now, before we get into the examples, okay, I want to go over the cones at the same time before we go to examples. Okay. Okay, so here, cones. A cone has a circular base and a vertex. Okay, so here's a cone. Again, the difference between the pyramid and a cone is that the cone has a circular base. A pyramid has a polygonal base. Okay. So again, a cone has a circular base, and the vertex is not in the same plane as the base. Again, the vertex is not on the base. The radius of the base is the radius of the cone. So the radius of the base is the radius of the cone. Okay, the height is a perpendicular distance between the vertex and the base. So height is from the vertex, it goes straight down. Okay. And again, the slant height is from the vertex to the edge of the circle. It says in the right cone, so the word right means it's straight, it's not slanted. Okay. So again, right cone means it's all straight. Okay, it's not slanted cone. Okay, in a right cone, the segment joining the vertex and the center of the base is perpendicular to the base. So again, this is perpendicular over here. Okay, so you can see that. So in a right cone, the height is perpendicular to the base. So you form the triangle. And notice that, so you need to notice the relationship between the slant height, the height, and the radius. Okay, they are right triangles, so it's going to be So it'd be r squared plus the h squared equal to L squared, right? A squared plus B squared equal to C squared. Okay. It says the lateral surface of the cone consists of all segments that connect the vertex with the points on the base. So lateral face means the face on the side. So if you cut and open up the cone, it's gonna look like this. Here's the base, okay, and when you cut and you open, it looks like it's a sector. Okay. Now it depends on the cone. This angle may be different, right? Okay. So surface area, when you cut along the slant height and the base edge and lay a right cone flat, you get a net shown at right. So this is the net. Remember, net is when you cut it open and let it flat. Okay. The circular base has an area of pi r squared, and the lateral surface is a sector of a circle. Okay, you can use a proportion to find the area of the sector as shown below. Okay, we did this before, right? Okay, so here is the formula. Okay, now, so that's going to sum up what we're talking about. Okay, and again, I prepared a handout for you guys. Okay, so I'm going to do this. Okay, I'm going to put the pyramid and the cone next to each other. Okay, so if you notice, again, it's easier to, this make more sense, it's easier to remember, okay? So the total area is equal to the lateral area plus one base, okay? Again, the total area equal to the lateral area plus one base. Now, if you notice, compared to the prism, right, that you have two bases. Notice over here, see, this has only one base, that's why it's 1B. This one has top and the bottom, so 2B. But notice formula, by doing it this way, by breaking it down, it's very easy to remember, okay? Okay, now, notice, next thing is that, notice the lateral area. The lateral, if you open it up, the lateral area is going to be a rectangle, okay? So if you open this up, I'm talking just LA, okay? If you open the prism, you're going to get something looks like this, okay? Whereas if you open up the pyramid, you're going to end up something like this. Okay? Now, notice the area of this is equal to base times height, okay? And the base would be perimeter, right? So it would be perimeter times height, okay? Where over here, okay, because the triangle, the area is 1/2 base times height, so lateral area will equal to 1/2 the base, again, is perimeter times height, okay? So that's where it came from. Now because this height is this straight up, right? But remember, h is this over here. That's h. The height of the triangle is right over here, which we have to use L. Okay, so this is L instead. So instead of using h, you have to use L. Okay, so that's a reason for that. Okay, so again, remember the h over here. This h is this right over here. So over here for the cone, the h is right over here. Okay, that would be the h. Whereas the triangle, the height of the triangle is L. Okay, so same thing with the cone. Okay, if you were to open the cone, okay, if you cut and you open the cone, your LA is going to look something like this. Okay, now notice it looks like a triangle. So the formula for a triangle, you can still use a triangle, okay? So again, the area of a triangle is 1/2 base. In this case, the base is what? The base is a circumference of the circle, so it'd be 2 pi r, okay? And the height, this would be the L, right? See, that's a height of the cone, okay? So that's why it's equal to 1/2. The base is 2 pi r. And the height of the triangle or the sector is L, okay? And notice this cancel out, and that's how you get pi r L, okay? That's why in the book, okay? But over here, just going to use 1/2. C is a circumference, so this is your C right over here, okay? That's a C. So basically, what you have is you have the 1/2. So this is 1/2 base times height. Okay, again, base, when you open it up, the base is 2 pi r. That's the circumference. Okay. Okay. So you can think about it when you open it up. Okay. So you can, when you open it up, when you open these things up, it looks like this. Okay. And area would be equal to 1/2 base is the circumference, the height is L. Okay, that's where they came from. Okay. Again, notice all these have half. Okay, if you notice, all this has half. Okay, because again, it's triangle, so area of a triangle is 1/2 base times height. When you open up, 1/2 base times height. Okay. So again, if you compare the formula, is very simple. Again, when you go straight up, you got 2 bases. That's why and when you have pyramid, when you got pointy top, you only get 1 base. So see the difference? So you got plus 2b plus 1b by looking at the picture. These have 2 bases, that's why it's 2b. These have only 1 base, that's why it's 1b. And the lateral area, because these are rectangles, so it would be base times height. Over here, because all these are triangles, so it would be 1/2 base times height. Okay? Same thing over here. Okay? Again, if you open it up, okay, when you open it up, the side, okay, again, if you look at the total area, it's a side plus 2 bases, right? Top and bottom. This one is only 1 base. See that? Okay? Again, if the area, the lateral area, circumference, right? When you open it up, the base is circumference, so it's base times height. Okay? Whereas this one, when you open it up, it looks like a triangle, so it will be 1/2 base times height. Okay? See that? Again, rectangle, base times height. Triangle, 1/2 base times height. Okay? Same thing over here. Rectangle, base times height. Triangle, 1/2 base times height. So again, if you understand the concept, you can actually, derive the formula without having to memorize it. Okay? Okay, so now let's go over some examples. Okay, so let's go to example 1. Okay, let's get rid of this book. Okay, it says find the area of the lateral area, lateral face of a pyramid. Okay, so you have this pyramid right over here. Okay, it gives you the height is equal to 15, and the base B equal to 16, and you're looking for LA. Okay. Let me see. Okay, a regular square pyramid has a height of 15 and the base edge length of 16. Find the area of each lateral face of, okay. So you're finding the area of a triangle. Okay, so you're looking for a triangle like this. So from here we know the base is 16 and the height is 15. So you need to draw this right over here. Okay. So you might have to draw multiple pictures. You need to find the L. Okay. So if you were to draw this picture, okay, this is 15. Now base is 16, so this would be an 8, right? Because see over here. So you have to be able to visualize, okay? And so this would be L. And remember from the spatial triangle, this is 8, 15, 17, right? Remember the spatial triangle, the 3, 4, 5, and the 5, 12, 13, okay? And if it's 7, it's 24, 25, right? And for the even number, it's 8, 15, 17, okay? Those are your spatial triples. So find a way each you're able to get 17. So make sure you go back and review your spatial triples. It saves you a lot of time. Now, if you don't remember that, then you have to do the Pythagorean theorem. You have to do it the long way. You have to go a squared plus b squared equal to c squared. You have to go 64 plus 225 equal to L squared. You're going to get 289 equal to L squared. So L equal to 17. Okay? So once you find L, so you have to turn this around now. Okay? So turn this face around. Okay? So this one you put over here. So this is L 17. Okay? So now you can figure out the area of this, right? So the area of one face I'm going to use K, would be equal to 1/2 base times height. Okay, so K of one face would be equal to. So again, when you solve the point, you got to draw pictures and help you to visualize. Okay. So K would be 136, and the label is centimeters square. Okay, so that would be the area of each face triangle. Okay. Okay, let's go to example 2. Find the surface area of a pyramid. Okay, it says find the surface area of a regular hexagonal pyramid. Okay, so you got hexagon. And again, if you look at this face right over here, okay, I'm going to turn the triangle this way. Okay, so it tells you that this is 14 feet and the base is 10 feet. Okay, and this over here, and the hexagon, the base. So you got to kind of draw out a picture. For the hexagon, the apothem is 5 square root of 3. Okay, and okay, so this is 5, 5, 10. That's your 36 spatial triangle. Okay, so you can draw out your picture. Okay, you're looking for the surface area. Okay, so the total area, again, equal to LA plus, now this has only one base, so it will be plus B. Again, write down your formula. Now you're going to break it down. Okay, so total area equal to, now the lateral area, so this is one face. Okay, so since we have all the information we need, so that's good. So the lateral area would be 1/2, so look at this triangle, 1/2 base times height, so there would be one triangle, and there are 6 of them, so you have to times it by 6. Okay, so again, 1/2 base times height, that's area of one triangle, one side, and there are 6 triangles, right? There are 6 sides, so times by 6. Plus, now here's the base. Okay, so you have to figure out the base. Okay, again, notice you got all the information you need already, right? So again, base. Okay, so let's go and do this triangle over here. So the base would be 1/2. Okay. So this whole base, the big B equal to 1/2 the small b. Okay, so 1/2 base times height, 1/2 base times height, and there's 6 triangles. Okay, if you divide it, so times by 6. Okay. Okay, so let's work it out. So use your calculator. Okay, so it'd be 420 plus, use a calculator. Okay, I like to kind of cancel things out, okay? Okay, so I'm going to use a square root first, so square root of 3, okay, times by 3, times by 5, times by 10. Okay, so I get 259.81. Okay, now go and add 420. I plus this together. So the total area equal to 679.81, and the label is feet square. Okay. So again, it's not too bad if you kind of use this logic, right? You can write down the formula and you break it down and draw pictures. Draw pictures to help you to visualize. Okay. Okay. One for the lateral side, right? The side and the base. Okay. And get all the dimensions in, that way you can use it to calculate. And if you notice, most of the time you boil down to finding the area of a rectangle or triangle. See, all these are all triangles. Okay. Okay. Let's go to example 3. Okay, what's the surface area of the right cone? Okay, so again, surface area, write down your formula. So the total area equal to the LA, the lateral area, plus, now this is a cone, so it has only one base. Okay? Okay, so now that's going to break it down. Okay, so LA, okay, is going to be, if you open this up, okay, so it's going to look something like this. Okay, and the base is going to be a circle. Okay, and the radius is 6. Now when you open these things up, okay, this is 8, and this is going to be 2 pi r. Okay. Again, if you open it, cut and open, the side going to look something like that. Okay, and so this is going to be equal to, now it's a triangle, so it would be 1/2. The base would be 2 pi r. Okay, so 1/2 the base, 2 pi r. Right, that's a circumference, right? 2 pi r, that's a circumference. Times the height, the slant height is 8, or actually back up. This is the h. So this is 6, 8, so this will be 10, right? Remember the triangle 3, 4, 5, double that would be 6, 8, 10, so it'll be a 10. So L equal to 10, so this would be a 10. When you open it up, this would be a 10, back up. Yeah. The height is the 8, but when you open it up, this would be the 10, okay, the 10, okay. So you have to be careful with that, okay. Now the area of a circle is pi r square. Okay, so this is a 10. Okay, so now use your calculator. Now again, if you don't know your spatial triple, you have to use Pythagorean theorem. Okay, you have to go a squared plus b squared equal to L squared, right? And then you have to go 36 plus 64 equal to L squared. You're going to get 100 equal to L squared, so L equal to 10. Okay. But make sure you know your triple. It's going to save you a lot of time. Okay. Okay, let's get a calculator. Let's work things out. Okay, so before you even start, right? Notice that 1/2 and 2 will cancel out, right? So it save you some work. So 6 times 10 would be 60. So it would be 60 pi. Okay. So I'm going to go 60 times pi. Okay, so it'd be 188.50. Okay, 4950. Okay. Now this side over here, pi r squared. So pi times 36 equal, okay, plus 113.10. Okay, now I'm going to add this. So plus 188.5. Okay, double check. I'm trying to double check something is not right. 1/2 pi RL. Oh wait, I'm looking. Okay. So in the book they ask you for pi. Let's back up. They don't want you to decimal. Okay. So if you add this, it will give you 60 pi plus 36 pi. Right? Yeah. So TA equal to 96 pi. Okay. Yeah. Okay. So answer would be B. Yeah. For this one, they don't need you to find out the actual number. Okay. So I was trying to look for it, and I didn't see the number on it, and I realized, oh, they live in terms of pi. Okay. Okay. Now let's go to example 4. Okay, so you have this cone right over here. Okay, it says the traffic cone can approximate by a right cone. So even notice that it's not a pointed top, but it just say approximate. Treat it as like a cone with a radius. Okay, so it's a cone with a radius of 5.7 inch and a height of 18 inch. Approximate the lateral area of the traffic cone. Okay, so you're looking for lateral area. Okay, so this one you don't have to write out the entire formula. So the lateral area, if you again you cut and you open, it's gonna look something like this. Okay, and again this would be the circumference, and this would be the L, right? Okay, so the area of these would be equal to 1/2 the base times the height. Okay, the height. So this would be CL, right? Base is CL, right? Now the C is the C is its circumference over here, so it would be 2 pi r would be 5.7. Okay. The L, you have to use Pythagorean theorem. Okay. So you have so you got a squared. This one is not like nice number, so you have to use Pythagorean theorem. So a squared plus b squared equal to c squared. Okay, the Pythagorean theorem. So go and work it out. So 5.7 squared plus 18 squared. So this would be 356.49 equal to L squared. Okay, I just use calculator, right? And then I'm going to take the square root of that. So square root of the answer. So it's 18.88. Okay. Okay, again, it's okay. It's better to go and carry extra digits and then run it off when you get to the final answer. Don't run it off too early because your answer may off by too much. Okay, but again, see, notice that 2 and 1/2 will cancel out. So you have to do is worry about this part over here. Okay, so that's going to work back. Okay, so 18.88 times 5.7 times pi equal. Okay, so K equal to 338.1. Okay. Now notice again, the answer is a little bit different from the book, inch square. The reason the answer is off a little bit because it depends on where you're running off your answer. Okay, but notice off by so little it doesn't matter. Okay, it's 0.1 versus 0.4, but see over here this is the main thing, right? So that's close enough.